Hello everyone. So this is a question from RE-NEET 2026. Given below are two statements. Statement 1. Oxidation of p-nitrotoluene with acidic KMnO4 gives an acid that is stronger than benzoic acid. And statement 2. Reduction of p-nitrotoluene with SnHCl followed by neutralization gives an amine that is more basic than aniline. Okay. So we have to determine which one is correct, which one is incorrect. The chapters involved is aldehydes, ketones, and carboxylic acid and amines. Okay, so in statement 1 we are starting with p-nitrotoluene or para-nitrotoluene, okay, which is this guy. So we have the benzene ring, and if I draw this is my toluene, and in the para position if I draw NO2, then this becomes my para-nitrotoluene. Okay, and it is oxidized with acidic KMnO4. Okay, so we should know that all alkyl benzenes, okay, important statement, all alkyl benzenes, okay. So alkyl benzenes are those guys which have an alkyl group attached to benzene. For example, this is an example of alkyl benzene. This is also an example of alkyl benzene, okay. Irrespective of chain length of alkyl group. So it does not matter what is the length of the chain of the alkyl group. Upon oxidation by acidic potassium permanganate, okay, all alkyl benzenes, irrespective of chain length of alkyl group, upon oxidation by acidic potassium permanganate, that is KMnO4, give benzoic acid. Okay, important. So therefore, para-nitrotoluene upon oxidation with acidic KMnO4 will give, that is with respect to reaction, I will have para-nitrotoluene and acidic KMnO4. So this group, this alkyl group will be converted to COOH. So therefore my product will be COOH and NO2. Okay, and the name of this guy is para nitrobenzoic acid. Okay, so now let's compare the acidity of para nitrobenzoic acid, that is this guy, and benzoic acid. So this is our benzoic acid. Okay, so one thing we should know is electron withdrawing groups decreases the electron density in OH bond. Very important. Electron withdrawing group decrease electron density in the OH bond. Okay, making the release of H plus ions easy. Making release of H plus ions easy. Okay, with respect to diagram, let's say we have an electron withdrawing group connected to the C double bond O OH bond. Okay, so electron withdrawing group will pull these electron away from oxygen. You can see I'm using these arrows. Okay, now since the electron density in oxygen is reducing, so this guy will pull these electron towards itself, due to which this bond can be easily broken and we can easily separate H plus, or we can easily produce H plus. So therefore, in a nutshell, EWG, that is electron withdrawing groups, increases acidity. Okay, and electron donating groups increase electron density in OH bond, making release of H plus ions difficult. Okay, That is, with respect to diagram, if you have a EDG, which is attached to a C double bond O, OH bond, so electron donating groups will donate electrons. So I'm showing it by using arrows. So therefore, electrons have been donated to this oxygen. So this oxygen doesn't feel the requirement to pull these electrons towards itself. So therefore, it is tough to break this bond and separate H plus. So therefore, in a nutshell, electron donating groups decreases acidity. Okay. So now coming back to para-nitrobenzoic acid, remember we have to compare the acidity of this guy and this guy. Okay. In para-nitrobenzoic acid, we have a NO2 group attached, which is an electron withdrawing group. Very important. NO2 group is a electron withdrawing group with respect to both inductive effect and a resonance effect. Okay. So according to inductive effect, so I will draw the structure of para-nitrobenzoic acid. According to inductive effect, you can see highly electronegative oxygen will pull the electron towards itself. Okay, because oxygen is very, very electronegative. So therefore, it's an electron withdrawing group with respect to inductive effect. With respect to resonance, you can see, I will draw the structure of NO2 in detail. So this is my NO2 in detail. So it can show resonance in which these electron pair goes to the oxygen and these electron pair forms a pi bond. Okay, so therefore the other resonance or the next resonance structure will be N O minus O minus, and there is a positive charge. Okay, so you can see according to resonance, these electrons are coming out of the system. So therefore NO2 is behaving as a electron withdrawing group with respect to resonance also, and therefore it is a electron withdrawing group with respect to both inductive effect as well as resonance effect. Therefore, due to presence of a electron withdrawing group NO2 in p-nitrobenzoic acid, that is, this is a electron withdrawing group, therefore it is more acidic than benzoic acid. Benzoic acid has just a COOH group attached to benzene. Okay, so therefore statement 1 is correct. Now coming to statement 2. So here we are starting with p-nitrotoluene again. So that is, we have this guy CH3, and in the para position we have NO2, and it is subjected to reduction with SnHCl. So plus reduction with, we are doing reduction in the presence of SnHCl. Okay, so we should know that nitro compounds, important, nitro compounds. So nitro compounds are compounds containing the NO2 group. So nitro compounds are reduced to amines in the presence of an active metal like Sn, tin, and concentrated HCl. Okay, important. So they are reduced to amines in the presence of an active metal like Sn and concentrated HCl. Okay, so therefore para-nitrotoluene upon reduction with SnHCl will give, that is with respect to reaction, this is my para-nitrotoluene, and in the presence of SnHCl, this NO2 will be converted into NH2. So I will get CH3 and NH2. Okay, so the name of this guy is p-toluidine or para-toluidine. Okay, it is also known as 4-methyl aniline. Okay, so now let's compare the basicity of this guy with aniline. So we have to compare this guy and aniline. Aniline is just NH2 attached to the benzene ring. Okay, we have to compare their basicity. Cool. So one thing we should know is that electron donating groups increases basicity. Okay, because it pushes the electron towards nitrogen atom. With respect to diagram, if a electron donating group is attached to the NH2, so it pushes electron towards nitrogen. Therefore, the electron density increases on nitrogen and hence the basicity. Okay, and electron withdrawing groups decreases basicity of amines. Okay, because it withdraws electron away from the nitrogen atom. With respect to diagram, electron withdrawing group connected to NH2, so it withdraws electron from away from the nitrogen atom, so therefore it decreases the electron density on nitrogen and hence the basicity. Okay, in p-toluidine or 4-methyl aniline, we have a CH3 group attached, okay, which is an electron donating group with respect to plus I effect, that is inductive effect, and hyperconjugation. Very important. So CH3 group is a electron donating group with respect to inductive effect and hyperconjugation. Therefore, due to presence of a electron donating group, that is CH3 in para-toluidine, that is this guy, there is a electron donating group. Therefore, it is more basic than aniline. Aniline just has a NH2 connected to the benzene ring. Okay, so therefore statement 2 is also correct. Okay, so therefore the final answer is statement 1 is correct, statement 2 is also correct. Okay, thank you.